Hello, another question here. This question is going to be number 1156, swap for longest repeated character substring. Let's give me a moment to make sure the audio is working and to pop out the chat. Just got the chat here. A moment. Let's give me a moment to make sure the audio is working and to pop out the chat. Good. Seems to be working. The chat here. A moment. What I'd like to see. Give me a moment. Now let me go ahead and okay. Let's keep going. So let's try this one next. So yeah, that last one wasn't too bad. That wasn't too bad. That was pretty straightforward. I just kind of made a mistake when I was doing it. It took longer than I should have. If you're given a string text, you can swap two of the characters in the text to return the length of the longest substring with repeated characters. Two of the characters. Length of the longest substring with repeated characters. Swap the first B with the last A or the last B with the first A. And the longest repeated character substring is AAA with length 3. Interesting question. Text is going to be 20,000 English lowercase letters. Okay. Something linear logarithmic. Linear rhythmic is what they're looking for. So yeah, I mean, let's see. I could go through each of the characters to figure out the sequences. Like what the substring repeated character substrings are, their positions and their lengths for each character, and I could do that in linear time. And then or linear times the size of the alphabet, which is constant in this case. And then I can move one character from one place to another. I really can only merge two at a time, I think. That's sort of the deal. I mean, the easiest thing to do is just loop through each character one at a time, get the largest substring, and then also note largest repeated substring for each character, and then also note that if there's a if one substring is separated by just one character from the other substring, then they could be merged. Trying to think. Pretty sure I could do this in like one pass too. Just need to keep track of like merge possible or something like that. Just keep track of the previous substring amount for each character. And then if the difference between the next one and the previous one is 1, then yeah, you could just swap one character and create the merge. Yep. And if there's another substring, if there's more than 2 substrings, just count the number of substrings. Or if there's more than 2, then actually that merge can be incremented by 1. So you don't have to use the merge amount can be incremented by 1 because you don't have to use the previous. There's a little bit of logic involved where the merge amount is these questions are so annoying. A little bit of logic involved where the merge amount is I don't want to keep track of this. Yeah, I can just, if I see 2 substrings separated by just one character, then they could be merged. And further, and then later, if I see if I see three separate substrings, then I can increment my result by 1. 3 or more, I can increment by 1. And the reason if I see 3 or more is that instead of swapping one of the characters from the 2 substrings that can be connected, instead of swapping one of those characters in, I could swap another character from outside in. And even if I don't see another like 2 substring, well, actually, yeah, even if I don't see 2 substrings that can be combined, any substring I can just swap a character there. To make it longer. I would say if I see, that's confusing. I can just keep track of the frequency. It's easier to do it that way. If I see 2, I'll keep track of the frequency as well as whether or not you know what I can do? I can keep track of the frequency first. Maybe I don't know. Trying to do it one pass. Trying to do it one pass. You know what I can do? I can keep track of if the largest value is a merged sequence. Keep track of a Boolean, and if it is, then also take into account the frequency. Yeah, because that's all like related. So if it's not a merged largest sequence, but there's the frequencies at least 2. Then I can increment by 1 that amount. If largest amount is not as a merged sequence and the frequency is not greater than or equal to 3, then I leave it as it is. But if it is a merged amount and the frequency is greater than or equal to 3 rather than 2, then I can also increment that result by 1. So there's like a few logical things going on there, but if I just keep track of the frequency and whether the largest amount that I see at this point is a merged amount, I'll get the wrong answer if I don't do that properly. Also, actually, it's like kind of complicated. Doing it in one pass is tricky. I have to sit and think about this for a while. Let me lay down and think about it. This is a little bit involved, the logic, actually, because if I could mess that up pretty easily. The way I could get messed up is that's a good question, because it really makes you like think through the issues involved. Excuse the details. Excuse me. Yeah, the problem is, what if I think I need to know what the frequency is beforehand, because the new merged amount might be larger than a previous amount that's not merged. I think I need to count the frequency first. Yeah. Okay, I'll do that. That's fine. Whatever, no big deal. 2 passes. 2 passes it is. That's fine. No big deal. Okay. Anyway, this is yeah. This should be a linear time solution. Although it's a fairly large constant doing this for each character. It's going to be 20,000 times 26 is like 500,000, something like that, and maybe doing it 2 passes. So yeah, I'll just code it. It's fine. All right, so we're gonna have for each int I0. Actually, you could even do char ch equals a. Ch is less than z, and increment char. It might even be better. Just do each character, and they're gonna have a frequency. Say for each character say current. For each of these characters, I want to say, oh no. Okay, do this a couple times. And we're going to count the frequency first. So if, let's do a for loop. Say for, let's do int j equals I, j is less than n, and text of j is equal to ch, increment j, count is going to be j minus I plus 1. So, how are we doing here? 11. This might take me a little while. It could be that it didn't move anywhere, and this could be just false. Oh no, this always has to be at least 1. Yeah. Whoa. What's that? This always has to be 1. It's actually not going to be 1. No. Current CH. Yeah. Okay. So while they're equal, I'm going to increment and take the difference, right? And it could just be 0 immediately. And then we're going to say count 1 and C2. And set this, I think I equal to j. Do this again, right? So I have 2 counts. First count is going to be the number of characters that are equal to the one I'm interested in. And the second one is going to be the number of characters that are not equal, right? And j is either off the edge or I think we said I equal to j again here. And I don't think I need to do this, by the way. J is either off the edge is one option, or it's going to be pointing to, at the end of this, it could be pointing to, it should be pointing to something that is the same character as current CH. It starts again. If it's not pointing to something like that, it'll skip this and initially basically skip this part and then go straight in here. And we're going to say frequency after each iteration is going to be C1 is greater than 0. That's the frequency. And the same piece of code I'm going to use for the second pass, which C2 is not the frequency, but it's going to be the result. So int best, int best is 0. I'm going to say there's another int here, which is int current best. And this, we're going to say current best is going to be equal to maximum of current best and C2. Now there's also previous as well as mergeable. And we'll say if, so mergeable is C2 is equal to 1, right? So for the next iteration, if C2 is 1, then the next iteration implies that this is mergeable, right? Now the question is, for the current best, we say if previously amount, let's just say amount, if it's mergeable with the previous amount, then we're going to take the amount and add to it the previous amount. And the previous amount is going to be set to C2, by the way. Okay. Now, also, if the frequency is greater than 3, frequency is greater than or equal to 3, then we add 1 here. So if it's mergeable, we put them together. If the frequency is greater than or equal to 3, I think at every point, if the frequency is greater than or equal to 3, we say okay, right. So if the amount is the count that I see, if it's mergeable with the previous amount, right, then I combine those two. And if the frequency is greater than or equal to 3 and it's mergeable, oh, I see. So if it's mergeable, then we say plus equals frequency is greater than or equal to 3. If it's not mergeable, right, we can say plus equals frequency is greater than or equal to 2. So that is kind of an interesting thing. Yes. Pretty sure that works. Yeah, that's really confusing, but I'm pretty sure that's correct. I think that's it. That's not that easy to realize. Like I said, the logic involved is a little bit complicated there. Logic involved there is a little bit complicated. How'd I do? Hoping I could just move on. I don't really want to spend too much time thinking about this. Output 3, 0, 0, 0. Okay, of course. Oh, no. And then at the end of this, current best gets updated with best. Forgot about that. Okay. Yeah, there might be some mistakes involved here. Okay, I got this one. These are wrong. 5, 7. So if it's mergeable, add the two together. And then if the frequency is greater than or equal to 3, add a 1. It's not mergeable. Then you could add another element. We're going left to right. I just add another element, really add another element to the right. It could be added to the left too, but previous mergeable is what this should be. It's a little bit more descriptive of what's going on here. Interesting. The previous is just C2. It's not going to be the total amount. There are some problems here. Why, okay, what happened here? Why did we get 5? Okay, how are we doing here? 20 minutes, alrighty. Okay, whoa. 1 1 1 1 1 0. Let me delete these cases. I just reset these, right? Get a little tired here. I kind of want to take a break. I don't know what's going on. Didn't do very much, but suddenly want to take a break anyway. Wait, this is all for one case? What? Why did this happen? What's going on here? Just looped like multiple times. C2 is 5? What? The heck? Huh. What is going on here? Huh? Oh, whoops! This is supposed to be C1, not C2. Duh. Oh, okay. That's a mistake. Maybe I should have labeled those a little bit better. Quite frankly, maybe I should have labeled those better. Whoops. There we go. Okay. Yeah, the logic for this is kind of involved, quite frankly. I'm trying to avoid using if statements as much as I can, but it's kind of a few details involved here. This is 20,000, so let me write a script to generate test cases again. Let me try it. Let me try to do this quickly this time around. I think this is correct, but it would be good to try a script. All right, here we go. So awk begin. Let's do get line, no, not get line, date. Plus %s, %n, get line seed, srand seed, and print rand. Now, what I want is k is 20,000. N is going to be 1 into 1 plus 20k times rand. I'm going to have a for loop. I'm going to print x. I'm going to say x is here. I is 0. I is less than n. Increment I. X equals x with a new So sprintf, there we go, sprintf %c int of 26 times rand plus I think 97, and then print x. There we go. Okay, and this is going to have an opening and closing, as well as for j in sequence 1 to 8. Do, done, good. Oh no, wrong. This way. This way. Okay, very good. A lot of characters, huh? Wow. 20,000 characters is a lot. Maybe computers are really powerful, I have to say. Look at this. This is amazing. Oh, I almost didn't copy the whole thing. Oof, it's close. I realized I didn't have to actually do the whole thing again. Okay. Very good. Nice. What's that for a script, huh? Let's do like 100. And let's do it a couple more times. And let's actually, this time around, let's restrict the different characters that I can see. Let's do it like three characters. Make this a little more complicated. I suspect most of these are, just 1 or 2 or something, and it's not very interesting. Let's do this a few times. Do 3 of them. Just because there could be unusual things going on here. In fact, let's go even deeper. Deeper, but just more in one direction. Okay. Let's see. All right, I am going to go for it. Could be wrong. Oh, got it. Okay, nice. Yeah, not too bad. Not too bad. Took 30 minutes. Okay, not great, but not terrible. We'll submit it a few more times. We'll submit it like 5 times total. Unfortunately, it's a little bit on the slower side because of how many times I'm looping. Doing kind of a lot of extra work here. It's doing 2 passes, and I'm doing 1 pass for each character. I think it's overall linear. It's not terrible, but it's, let's see, 1, 2, 3, 4. But it's definitely probably could be improved, quite frankly. I probably could do. I'll submit this one more time. I probably could. Probably could do these things simultaneously, like the sequences themselves. I could probably do this in 1 pass. Is what I'm saying. I could probably make this a lot faster. Yeah, instead of going character by character in this way, I can just increment the frequency for a particular character when I see it, and just have a frequency for each character, and then similarly, have an array of what's mergeable as well, and what the previous amount is. The array of previous values is as well as mergeable values, as well as the previous current best values for that particular character. Right, just have an array of each of these things, and then process those things here as well in like an array. Instead of mapping it this way, I can map it that way, if that makes sense. Like mapping it, instead of mapping from each single character one at a time, I could do all the characters at each point, and then and map those appropriately. This frequency, yeah, I mean, it would no longer be checking if it's not equal to this current character. It would just be checking each character sequence individually and incrementing the appropriate frequency. And then similarly over here, the second pass, I would be checking the sizes of the previous sequence in between the next sequence. I guess I'd have to check like 3 sequences at a time. I'd have to be a little more finagled, I think, to do it in slightly faster runtime, but it's very similar code. I'm sure we need to think about a little bit more exactly how to do it. It's a little more involved, but I think it can be done. But this is still reasonably fast. This is not terrible. Still linear time. Still beats a lot of the examples. But I think you could modify this and do the frequency. Definitely could do the frequency. It's actually pretty clear to be able to do that. But as one pass and not as multiple passes here. And then here, this as another pass, I think could be modified to basically have the same logic, but apply to all of the different possible character values instead of just one at a time. Yeah, so anyway, either way, not bad. So thanks for watching. Talk to you soon. If you like this video, give it a like and subscribe for more. And I think I want to take a break. I don't know, for a few minutes maybe. But the plan is to start another question, start the stream again on another question, and keep going. See how